Hello there, Math 126 fans. Somebody's asking me about this question that has to do with a space curve. So I think there's just terminology scaring people here. A space curve means a curve drawn by an astronaut on the International Space Station. That's a joke, I'm sorry. A space curve means a 3D curve, is all that means. So in math, we talk about plane curves, meaning curves drawn in 2D, and space curves. That terminology came up in the homework. It's not something we used a ton, but this was just saying, find the equation of the surface that contains the curve you just found. So these are all talking about the same thing. So I think the word space curve threw someone off. I think I did this question in one of my review sessions, but let's do it again since it's being asked here. Okay, so this is an opportunity for us to practice our integration. Basically, we're integrating this vector function, which is 3 cosine of t. Again, we think about this as the velocity in the x direction. We think about this as the velocity in the y direction. We think about this as the velocity in the z direction right here. And then we integrate component-wise. It's really just 3 separate problems. So we're going to say 3 sine of t plus c1. Oh, I remember doing this. So we definitely did this during our Zoom review, I did this. But I'll say something more about the other parts because that's what the student was asking about. Okay, so we just found our space curve. I do remember the first time I heard that, I was like, that does make it sound like it's sci-fi or something. Okay, now we're going to put in our initial condition. Our initial condition is when we plug in 0, and don't forget about that fact of plugging in 0. Now, in this case, that doesn't matter. You're going to get 2. And then when I plug in 0, you're going to get 1. And then when I plug in 0, you're going to get negative 1. So what does that mean? Well, 3 times 0 plus c1 is 2, so c1 has to be 2. 0 plus c2 has to be 1, so c2 is 1. This one, when I plug in 0, I actually get negative 1 plus c3 equals negative 1. So c3 is actually 0. All right, we have done it. The space curve is 3 sine of t plus 2t squared plus 1 negative cosine of t. Done, done, done. Okay, now to what the student was asking about. Find the equation of a surface that contains this. There are many correct answers. It's asking you to eliminate the parameter. To me, there are 3 natural answers, and there is one best answer, in my opinion. Okay, so we would have this is 3 sine of t plus 2. The idea of an equation of a surface that it's on is this idea of a surface of motion. I've actually answered that quite a few times on the discussion board because people have been asking me this. This is this idea of sometimes we have an intersection and we want to parameterize it. That's one place we use this. Another is we have a curve and we want to visualize it. That's what's happening here. So the question is asking you to put 2 of these together. And that's why I say there are multiple answers. You could put those 2 together, which is the best. You could put these 2 together, which is fine. You could put these 2 together. Each of those will lead to a surface that the motion is happening on. The ones that involve the y are messier because if you go to solve for the t, you're going to have 2t squared equals y minus 1. So you'll have t squared is y minus 1 over 2. And you get t as the square root of that, and then you'll substitute in here, and it will look gross. Cosine of plus or minus the square root of y minus 1 over 2. I would accept that, though. That is a surface this is on. It's just not easy for me to visualize. So what's the other strategy besides solving for a t? The other strategy is to look for sines and cosines, and we have those here. And so then I'm suspicious that there's some sort of circular motion happening here. And what we know is that cosine squared plus sine squared has to be 1. Cosine is negative z, but negative z squared is the same as z squared. And sine of t would be x minus 2 over 3. So that's the strategy. This is actually an ellipse. So that would make it easier to visualize. So if I made a 3D visual of that elliptic cylinder, every point on this curve is on there. So that helps us visualize. Okay, so then it says, what's the curvature at pi? That's a straight computation problem. It's asking for r prime of pi cross r double prime of pi. You get the magnitude, and then you're going to divide by r prime of pi cubed. And so it's a straight plugging in. Now r prime we already know. It's up here. It's what the problem gave us. R double prime we haven't computed yet. So let's just write this. R prime, I'll just rewrite it so we can see it. This is 3 cosine of t. This is 4t. This is sine of t. And the derivative of this is negative 3 sine of t for cosine of t. And then we're plugging in pi everywhere. So now that we've taken the derivatives, we can plug in pi. That's going to be negative 3 because that's cosine of pi is negative 1. This is going to be 4 pi. This is going to be 0. We're going to do the cross product of that with, when I plug in a pi over here, which is going to be 0, 4, 1, divided by the magnitude of the derivative, so the magnitude of this, negative 3, 4 pi, 0, cubed. So I think I'm going to stop because I need to get on to other questions. I've been answering questions for 3 hours. I really want to get them all off the board before tomorrow. Okay, so you're going to do this cross product, compute the magnitude, but I hope that answers your question.